All right. This is a quick case study on an existing building because we just talked about a building that doesn't really exist yet, right? And so it's great when we have the opportunity to start at the very beginning of design and work through the process. But what happens when you have an existing building that would like to do better or would like to maybe even go for net zero, but it's already built? So we're going to run through this real quick. Selma was nice enough to get me this case study. It's a residence in Sarasota, right? Yep, a residence in Sarasota. It's about 2,000 conditioned square feet of space, but it has about over 3,000 square feet of roof because it has a massive overhang that comes over this pool. And so I want to show you what we can do with very limited information, right? I mean, Selma, you did get me a lot of information too, but there was some, they had some limitations getting all the stuff. And that's not uncommon. A lot of times I'll just get a handwritten, like, this is what we did for the last 12 months. And I kind of have to go figure it out, right? And so this is what I received primarily, right? Was this from the owner?
Yes, from the owner.
Perfect. So I received this from the owner. They gave me, which is actually a lot more than I usually get. September 2018 through July 2019, then August 2019 through August 2020. So a full 2 years, 24 months of data. And
I wrote it in the chat line, but everybody, this is the Umbrella House by Paul Rudolph after the renovation. The idea being it's Sarasota school architecture. How's it doing if we modeled it?
Mm-hmm. Yeah. And so what ended up happening, we were going to do this as another exercise. I was going to break everyone out into 4 teams if we had more people, and we were going to, 2 of the teams were going to compete with the middle school, 2 of the teams were going to compete bringing down the energy use of this house. But we just didn't have the numbers for that. So instead I decided to run through a quick, what I typically do for existing buildings when they want to try and hit net zero. So this data is great and I used it, but these notes that the owner happened to write, like very kindly write down, because we don't always get this level of information, actually is what helped me the most. So first things first, I knew it was FPL. So I had to, this is blurry, sorry, but I had to go to FPL and dig out their residential utility rates because I didn't know what they were, and make sure I knew what they were paying. And then I took their data and I graphed it. And that's all I did. I just took their KWH. I also created how much they're paying. Obviously, when you're only using electricity, they didn't give me any other utility. Like they might have natural gas. I didn't get it. They
don't have anything else.
Perfect. So when you have only one utility, obviously your cost is going to track very closely to your consumption. The utility rate, I just used 10.5, so 10.5 cents per kWh is what FPL looks like they're charging customers. So that's what I used. And I just like to look at it visually because first I need to make sure it looks right, that the shape looks right. So you'll see in the down energy use, it's December, January, February. In the up, in the high energy use, it's June, July, August. This is very typical. This is what we would see. So what I can tell by this is that there's no crazy process loads happening inside the building that's causing a flatter curve. It's a very weather-driven house, and the energy use is extremely weather-driven. Let's scooch to here. And then I always look at it compared to the cooling and heating degree days, because like maybe it was a hot year, maybe it was a cold, but maybe the summer wasn't that bad that year, which is obviously not the case. But this blue line represents the cooling degree days, which basically your cooling energy should follow that. And this red line follows heating degree days, where in our climate, you should have the lowest amount of energy use when that heating is peaking. In the case of these buildings, or this building, it's, I believe, a heat pump, which is very typical for a residential application, which means that it's a very efficient way to heat your house, basically. It's not using all just electric heat. Okay, so I looked at this and I was like, okay, great. Nothing crazy, nothing wild is going on here. And I tried, we were talking about EUI, right? So this house's EUI is about a 71 EUI, and houses are a little funky because they're 24/7 a lot of times. You don't have operating hours for a house. And so it wasn't out of the normal range, in my opinion. However, Energy Star, which is what I'll go to check it against like buildings, doesn't have an Energy Star rating for houses, for single family residences. So I'm just showing you the process. I wasn't able to compare it against like houses, but I was able to compare it against my house and other houses that I worked on. And I feel like this isn't out of the normal range of a house. So then I was like, okay, what's it going to take to get this thing to net zero, right? It has a lot of roof space, which is great. I was able to go on to the property. So this is what I do. Like I kind of feel like I'm stalking people sometimes, but I went onto the property appraiser's website to find out how many bedrooms and baths there were, because that plays into the energy use intensity. And I went onto Google Maps and got the roof area just from a quick measurement. And I did take that hole in the roof out, and then took about 10% more off, because you have to, if you're going to put a PV array, you have to be able to walk around it and have space to walk. So I take 10% out of the total roof area in order to get a more accurate PV array size. Then I go into, so this is called PV Watts Calculator. It's free, available online and through the National Renewable Energy Lab, NREL. And it's extremely easy to use. That's this left-hand side, right? I have my own little Excel calculator that I throw some numbers into. And so this top line here is their total annual kWh for the year, and how much they're paying, and the amount of available roof area that I think they can use. And then I play around with the sizing of the array, because I have some rules of thumb that I use. You can fit about 16 watts per square foot of PV on a roof. So I know that kind of contains my PV size. And I come up with an array size that I think is the max that they can fit on their roof. So that was a 61 kW array. And a 61 kW array, according to PV Watts, gets us about 98,000 kWh per year, which actually ends up being more than double what they're actually using. So, okay, I answered my first question. Can this project be or can this house go net zero with its available roof space? The answer is yes. So then just to basically reduce the initial first cost of that array, I brought it down to see what it would take to be net zero, but not overdo it, not double, the capacity, or not put so much PV that they're doubling what they actually use. And we were able to go from a 61 kW array down to about a 27 kW array, which hits just over 100% of their energy use. And then I was saying, the notes were the thing that really helped me out a lot. And the reason is, if you read through these, you'll find out that the house is basically occupied 2 months out of the year, maybe, and over the course of those 24 months, and that they have rather, they have elevated humidity issues in the house because they have jalousies windows, which are not good. Jalousies are very not good. And so that's going to elevate your energy use. So I was thinking, well, if anybody decided to live here full time, then obviously the energy use is going to go up. So I said, you know, based on all this and the notes and everything that I looked at, and by the way, this activity took me 20 minutes to do. That's it. I said, I think they should, you know, if they can afford it, max out their roof, because one day if they rent it out or if they occupy it all year round, they'll still be net zero. So that was it. That I just wanted to show you that exercise. That's something that we do a lot. I just did it for another building that we have that had some questions about their energy use. And that's really it. All of that is available online for free and very easy and, you know, intuitive to use.